If you use fluorescence microscopy, I am sure that you will be aware of the many shortcomings of conventional high-pressure mercury and metal halide lamps used as light sources. Illumination is unstable and decreases over time. Replacement bulbs need to be fitted and aligned every few hundred hours. And with mercury, you need to pay special attention with their disposal. In use, they generate considerable amounts of unwanted heat. This can cause focus drift and reduce the life of mechanical parts such as shutters. What's more, these lamps also generate light at unwanted wavelengths, particularly UV, which can bleach samples. And as they have to transmit the broad spectrum, light guides used on metal halide lamps also need replacing regularly. As you know, conventional lamps need time to warm up and cool down, so you have to plan your research around this wasted time. So all in all, not ideal light sources. At CoolLED, we have developed a range of modular light sources based on solid-state LEDs, which give you simpler operation. But probably more importantly for research activities, it gives you better control over the excitation light. With fast switching, long-term stability and repeatability, you can have a high-intensity light source that is simple to integrate into your fluorescence imaging systems. And these light sources can be fitted to all current microscopes. To maximize intensity, stability and lifetime, CoolLED builds its products from arrays of actively cooled LEDs. These arrays are mounted into interchangeable LED array modules, LAMs, each of which can carry 2 different wavelengths. As we manufacture these from the bare LED die, we're not limited to the wavelengths offered for standard packaged parts. This means we can offer LEDs matched to your fluorophores and filter sets. You will be impressed with the intensity. Here you can see green excitation on a sample slide. This is a chart showing the current range of 20 LED wavelengths which CoolLED offers. You can see that these have been developed to match many of the common fluorophores. We are constantly adding new LED wavelengths. CoolLED's modular systems allow the user to select their preferred wavelength combination from this range. Common wavelength combinations for fixed cell work are DAPI, FITSI, Psi3 and Psi5. And for those engaged in live cell using CFP, YFP and GFP, RFP, these are widely used pairs for dual staining. There are so many benefits to LEDs, but a few of the most important are instant on-off, microsecond switching, no more costly replacement bulbs, shutters or light guides, no more bulb changing and aligning, no more lamp failures during time-lapse experiments, no more instability through thermal drift. So now you can replace the mercury or metal halide on your microscope. A 4-wavelength PE system is made up of these parts: the main unit, which houses the LEDs and the actively cooled system, 2 user-exchangeable LAM modules, liquid light guides to deliver light from each LED module, a simple-to-use control pod, and a combining collimator fitted directly onto the microscope. The PE system is simple to install. All you have to do is remove the old mercury housing or metal halide attachment. Then the CoolLED combining collimator can be fitted in its place using a matching adapter. 2 light guides connect between the main unit and the combining collimator and are held in place by lightly tightening the thumb screws. Once fitted and connected to the control pod, the unit can be switched on and off with the simple push of a button. The main control knob is used to increase or decrease intensity in 1% steps. You have independent control over each wavelength. Selection of the desired wavelength is made from the control pod. The different LED wavelengths can be switched on and off in sequence or illuminated simultaneously. And you can switch the LEDs on and off as many times as you like. It will not harm them in any way or shorten their life. When first installed, a small adjustment of the light guides is necessary to optimize the brightness and to fill up the illuminated field of view. By gradually drawing back the light guides from the collimator, you can observe how the illumination increases in brightness. These are then set at the position where the field of view is covered at maximum brightness, and once set, you should never have to adjust these again. As you will know, successful fluorescence microscopy means that you have to make sure that you match up the filter set with the fluorescent dye you are using. This requires verifying that the excitation filter in the cube only passes those wavelengths required to excite the dye, and that the dichroic in the cube needs to separate the excitation wavelengths from the emissions. and the emission filter limits the wavelengths that you either view or image. This has to be addressed regardless of the excitation light source being used. With LEDs, it is only a simple further step to include the selection of the LED wavelengths when matching filters with fluorophores. In fact, with LEDs, you are only generating the desired wavelengths of light. Unlike the broad spectrums generated from mercury and metal halide sources, unwanted wavelengths, particularly in the UV and near-infrared regions, are not present. This narrow band of light being generated and delivered to the microscope from LEDs reduces the instance of photobleaching and phototoxicity, so you get less damage to your dye and cells and reduced background from stray light. And all of this means that LEDs can give you more control over your experiments. As a solid-state product, control and automation are simple. You can control the switching and intensity of the LEDs remotely via USB port. For the fastest switching times, PE products accept a TTL trigger input for sub-millisecond control. This is much quicker than any mechanical shutter or filter wheel. CoolLED's modular wavelength products are fully integrated under most imaging software packages, such as Metamorph or NIS Elements, Slidebook, Image Pro, or Micromanager. All these features mean that it is now possible to have a fully automated, solid-state microscope illumination system with no moving parts. No ND filters, no shutters, no vibration, no delay, just controllable light at your fingertips. Long lifetime is a key feature of LEDs. CoolLED's LED products are designed to last for at least 10,000 hours. You have repeatable illumination with high temporal stability, great for quantitative work such as FRET experiments, and it is ideal for long-term time-lapse work as there is no fluctuations over time. But remember, by switching the LEDs on when you're reviewing samples or imaging and off for the rest of the time, you should expect a CoolLED light source to last for at least 15 to 20 years, so no more bulb replacements or alignment again. LED wavelengths can be changed by replacing the modules, the lamps, within the main unit. Simply remove the front panel and then release the individual lamp. Replace with a new lamp and reconnect the flexible cable. The system will reset automatically and recognize the new wavelengths. Depending on the wavelength selected, you may have to change the diachroic in the combining collimator. This must be optically positioned between the lower wavelengths in the left-hand channel and the higher wavelengths in the right-hand channel. An added benefit of delivering light through two separate channels is the ability to place excitation filters in the optical paths of the light source using our PE2 collimator. This is attractive for dual staining applications where an excitation filter wheel is normally used. The filter wheel is now redundant and replaced with fast switching, no vibration, no delay, solid-state LED light. So join the many researchers worldwide who are recognizing the advantages of LED illumination for their science and enjoying intense, controllable illumination without the inconvenience and cost of mercury or metal halide lamps.